In this lesson, we are going to work on exponential and logarithmic functions. As we saw in our previous courses, if a to the power of x equals b, then x is log of b base a, and vice versa, provided that a and b both are positive and a is not 1. This means the inverse of the function f of x equals a to the power of x, a to the power of x, is g of x equals log of x base a, and the other way around. Limit of 1 plus 1 over x to the power of x as x approaches infinity, which is the same as limit of 1 plus x to the power of 1 over x as x approaches 0, is approximately 2.7183. This can be shown by a table of values. By definition, e, which is a constant in math, limit of 1 plus 1 over x to the power of x as x approaches infinity, or limit of 1 plus 1 over x to the power of x as x approaches 0. E is an irrational number and approximately 2.72. Log of x base e, which is called natural log, is denoted by line of x. If we consider f of x equals e to the power of x, its inverse would be log of x base e, which is the same as line of x. The graph of e to the power of x is the graph of an exponential function with base more than 1. It is always increasing and concave up. Y-axis is, x-axis is the asymptote. Its domain is all real numbers, and range is all positive numbers. The graph is actually between y equals 2 to the power of x and y equals 3 to the power of x. The graph of the inverse function is the mirror image about y equals x, which is the graph of y equals line of x, the curve drawn by red in this diagram. It's always increasing and concave down. The domain of f of x equals line of x is the same as range of y equals e to the power of x, and its range is the same as domain of y equals e to the power of x. Therefore, the domain of line of x is all positive numbers, and its range is all real numbers. Y-axis is the vertical asymptote of f of x equals line of x. Let's work a little bit with natural log. Example 1. If e to the power of a is b, then line of b is a and the other way around. This is similar to saying log of b base e is a using the main definition. Generally speaking, if e to the power of x is a, then x is line of a and the other way around. Obviously, a must be positive, and base is e, which is approximately 2.71. If e to the power of x is 2, x is line of 2, and line of 2 can be calculated using a calculator. We know log of a base a is 1 when a is a positive number and not 1. Therefore, log of e base e is 1. That means line of e is 1. Let's expand line of a5, b3. We know log of multiplication is addition of logs. Therefore, line of a5, b3 is line of a5 plus line of b3. Log of an base b is n log of a base b. Therefore, line of a5 is 5 line of a, and line of b3 is 3 line of b. Similarly, line of square root of a over b2 is line of square root of a minus line of b2. Log of division is subtraction of logs. The exponent of a is 1 over 2. Therefore, line of square root of a is 1 over 2 line of a, and line of b2 is 2 line of b. Let's find the inverse of one exponential and one logarithmic function. F of x equals e to the power of x minus 2. To find the inverse, we call f of x y, we exchange x and y, and we isolate it for y. X is e to the power of y minus 2. Therefore, y minus 2 is line of x. This means y equals line of x plus 2. Therefore, f inverse of x is line of x plus 2. If f of x is line of x minus 1 minus 3, y is line of x minus 1 minus 3. If we exchange x and y, x would be line of y minus 1 minus 3, and we isolate y. X plus 3 is line of y minus 1. We know if line of a is b, a is e to the power of b. Therefore, y minus 1 is e to the power of x plus 3. This means the inverse of f of x equals line of x minus 1 minus 3 is e to the power of x plus 3 plus 1. If we use a table of values, we can see limit of e to the power of x minus 1 over x as x approaches 0 is 1, and limit of 1 over x, line of 1 plus x as x approaches 0 is also 1. We use these limits to find the derivative of f of x equals e to the power of x and f of x equals line of x. In our next lesson, we see the derivative of e to the power of x is e to the power of x itself, and derivative of line of x is 1 over x. Thanks for watching.